Data visualization or data visualization is a modern branch of descriptive statistics. It involves the creation and study of the visual representation of data, meaning information that has been abstracted in some schematic form, including attributes or variables for the units of information. The main goal of data visualization is to communicate information clearly and efficiently to users via the information graphics selected, such as tables and charts. Users may have particular analytical tasks, such as making comparisons or understanding causality, and the design principle of the graphic follows the task. Tables are generally used where users will look up a specific measure of a variable, while charts of various types are used to show patterns or relationships in the data for one or more variables. Overview: according to Friedman, the main goal of data visualization is to communicate information clearly and effectively through graphical means. It does not unregistered trademark T mean that data visualization needs to look boring to be functional or extremely sophisticated to look beautiful. To convey ideas effectively, both aesthetic form and functionality need to go hand in hand, providing insights into a rather sparse and complex data set by communicating its key aspects in a more intuitive way. Yet designers often fail to achieve a balance between form and function, creating gorgeous data visualizations which fail to serve their main purpose to communicate information. Indeed, Fernando Viegas and Martin M. Wattenberg have suggested that an ideal visualization should not only communicate clearly, but stimulate viewer engagement and attention. Data visualization is closely related to information graphics, information visualization, scientific visualization, exploratory data analysis and statistical graphics. In the new millennium, data visualization has become an active area of research, teaching and development. According to Post al., it is united scientific and information visualization. Brian Willison has demonstrated that data visualization has also been linked to enhancing agile software development and customer engagement. KPI Library has developed the AEO periodic table of visualization methods, an interactive chart displaying various data visualization methods. It includes 6 types of data visualization methods: data, information, concept, strategy, metaphor and compound. In February 2014, University of Toronto professor Nadia Amoruso demonstrated how data visualization techniques increase the understanding of big data sets in order to communicate a story at the University of Waterloo Stratford Campus Inspiration Day. Characteristics of effective graphical displays. In his 1983 book The Visual Display of Quantitative Information, Edward Tufte defines graphical displays in the following passage: graphical displays should show the data, induce the viewer to think about the substance rather than about methodology, graphic design, the technology of graphic production or something else, avoid distorting what the data have to say, present many numbers in a small space, make large data sets coherent, encourage the eye to compare different pieces of data, reveal the data at several levels of detail, from a broad overview to the fine structure. Serve a reasonably clear purpose, description, exploration, tabulation or decoration, be closely integrated with the statistical and verbal descriptions of a data set. Graphics reveal data. Indeed, graphics can be more precise and revealing than conventional statistical computations. The Maynard diagram shows the losses suffered by Napoleon's army in the 1812 to 1813 period. 6 variables are plotted: the size of the army, its location on a 2-dimensional surface, time, direction of movement, and temperature. This multivariate display on a 2-dimensional surface tells a story that can be grasped immediately while identifying the source data to build credibility. Edward Tufte wrote in 1983 that, "It may well be the best statistical graphic ever drawn." Data visualization scope. There are different approaches on the scope of data visualization. One common focus is on information presentation, such as Friedman presented it. In this way, Friendly presumes 2 main parts of data visualization: statistical graphics, and thematic cartography. In this line, the data visualization, modern approaches article gives an overview of 7 subjects of data visualization, articles and resources, displaying connections, displaying data, displaying news, displaying websites, mind maps, tools and services. All these subjects are closely related to graphic design and information representation. On the other hand, from a computer science perspective, Fritz H. Post categorized the field into a number of subfields: information visualization, interaction techniques and architectures, modeling techniques, multi-resolution methods, visualization algorithms and techniques, volume visualization, for different types of visualizations and their connection to infographics. See infographics. Activities of data visualization users. Professor Edward Tufte explained that users of information displays are executing particular analytical tasks such as making comparisons or determining causality. The design principle of the information graphic should support the analytical task, showing the comparison or causality. Low-level user analytic activities while interacting with an instance of data visualization are presented in the following table. This taxonomy of user activities can be used on 2 occasions: while discovering user requirements for particular data visualization project, and during evaluation of a data visualization technique. The taxonomy can also be organized by 3 poles of activities: retrieving values, finding data points, and arranging data points. This organization is displayed in the following diagram. Quantitative messages. Author Stephen Few described 8 types of quantitative messages that users may attempt to understand or communicate from a set of data and the associated graphs used to help communicate the message. Time series. A single variable is captured over a period of time, such as the unemployment rate over a 10-year period. A line chart may be used to demonstrate the trend. Ranking. Categorical subdivisions are ranked in ascending or descending order, such as a ranking of sales performance by salespersons during a single period. A bar chart may be used to show the comparison across the salespersons. Part to whole. Categorical subdivisions are measured as a ratio to the whole. A pie chart or bar chart can show the comparison of ratios, such as the market share represented by competitors in a market. Deviation. Categorical subdivisions are compared against a reference, such as a comparison of actual versus budget expenses for several departments of a business for a given time period. A bar chart can show comparison of the actual versus the reference amount. Frequency distribution showed the number of observations of a particular variable for given interval, such as the number of years in which a given stock market return is between intervals such as 0 to 10%, 11 to 20%, etc. A histogram, a type of bar chart, may be used for this analysis. Correlation, comparison between observations represented by 2 variables to determine if they tend to move in the same or opposite directions. For example, comparing corporate profits and stock market levels for a sample of years. A scatter plot is typically used for this message. Nominal comparison, comparing categorical subdivisions in no particular order, such as the sales volume by product code. A bar chart may be used for this comparison. Geographic or geospatial, comparison of a variable across a map or layout, such as the unemployment rate by state or the number of persons on the various floors of a building. A cartogram is a typical graphic used. Examples of diagrams used for data visualization, related fields. Data acquisition. Data acquisition is the sampling of the real world to generate data that can be manipulated by a computer. Sometimes abbreviated DAQ or DAS, data acquisition typically involves acquisition of signals and waveforms and processing the signals to obtain desired information. The components of data acquisition systems include appropriate sensors that convert any measurement parameter to an electrical signal, which is acquired by data acquisition hardware. Data analysis. Data analysis is the process of studying and summarizing data with the intent to extract useful information and develop conclusions. Data analysis is closely related to data mining, but data mining tends to focus on larger data sets with less emphasis on making inference, and often uses data that was originally collected for a different purpose. In statistical applications, some people divide data analysis into descriptive statistics, exploratory data analysis, and inferential statistics, where the EDA focuses on discovering new features in the data, and CDA on confirming or falsifying existing hypotheses. Types of data analysis are: exploratory data analysis, an approach to analyzing data for the purpose of formulating hypotheses worth testing, complementing the tools of conventional statistics for testing hypotheses. It was so named by John Tukey. Qualitative data analysis or qualitative research is the analysis of non-numerical data, for example words, photographs, observations, etc. Data governance encompasses the people, processes and technology required to create a consistent, enterprise view of an organization's data in order to decrease the risk of regulatory fines, designate accountability for information quality, improve data security, increase consistency and confidence in decision-making, maximize the income generation potential of data. Data management comprises all the academic disciplines related to managing data as a valuable resource. The official definition provided by DAMA is that data resource management is the development and execution of architectures, policies, practices, and procedures that properly manage the full data lifecycle needs of an enterprise. This definition is fairly broad and encompasses a number of professions that may not have direct technical contact with lower-level aspects of data management, such as relational database management. Data mining is the process of sorting through large amounts of data and picking out relevant information. It is usually used by business intelligence organizations and financial analysts, but is increasingly being used in the sciences to extract information from the enormous data sets generated by modern experimental and observational methods. It has been described as the non-trivial extraction of implicit, previously unknown, and potentially useful information from data, and the science of extracting useful information from large data sets or databases. In relation to enterprise resource planning, according to Monk, data mining is the statistical and logical analysis of large sets of transaction data, looking for patterns that can aid decision-making. Data transforms is the process of automation and transformation, of both real-time and offline data from one format to another. There are standards and protocols that provide the specifications and rules, and it usually occurs in the process pipeline of aggregation or consolidation or interoperability. The primary use cases are in integration systems organizations, and compliance personnels. Data visualization software, data presentation architecture. Data presentation architecture is a skill set that seeks to identify, locate, manipulate, format and present data in such a way as to optimally communicate meaning and proffer knowledge. Historically, the term data presentation architecture is attributed to Kelly Lout. Data presentation architecture is a rarely applied skill set critical for the success and value of business intelligence. Data presentation architecture weds the science of numbers, data and statistics in discovering valuable information from data and making it usable, relevant and actionable with the arts of data visualization, communications, organizational psychology and change management in order to provide business intelligence solutions with the data scope, delivery timing, format and visualizations that will most effectively support and drive operational, tactical and strategic behavior toward understood business goals. DPA is neither an IT nor a business skill set but exists as a separate field of expertise. Often confused with data visualization, data presentation architecture is a much broader skill set that includes determining what data on what schedule and in what exact format is to be presented, not just the best way to present data that has already been chosen. Data visualization skills are one element of DPA. Objectives. DPA has two main objectives: to use data to provide knowledge in the most efficient manner possible, to use data to provide knowledge in the most effective manner possible. Scope. With the above objectives in mind, the actual work of data presentation architecture consists of creating effective delivery mechanisms for each audience member depending on their role, tasks, locations and access to technology, defining important meaning that is needed by each audience member in each context, determining the required periodicity of data updates, determining the right timing for data presentation, finding the right data, utilizing appropriate analysis, grouping, visualization, and other presentation formats. Related fields. DPA work shares commonalities with several other fields, including business analysis in determining business goals, collecting requirements, mapping processes. Business process improvement in that its goal is to improve and streamline actions and decisions in furtherance of business goals. Data visualization in that it uses well-established theories of visualization to add or highlight meaning or importance in data presentation. Graphic or user design. As the term DPA is used, it falls just short of design in that it does not consider such detail as color palettes, styling, branding and other aesthetic concerns, unless these design elements are specifically required or beneficial for communication of meaning, impact, severity or other information of business value. For example, choosing locations for various data presentation elements on a presentation page in order to convey hierarchy, priority, importance or a rational progression for the user is part of the DPA skill set. Choosing to provide a specific color in graphical elements that represent data of specific meaning or concern is part of the DPA skill set. Information architecture, but information architecture's focuses on unstructured data and therefore excludes both analysis and direct transformation of the actual content into new entities and combinations. Solution architecture in determining the optimal detailed solution, including the scope of data to include, given the business goals, statistical analysis or data analysis in that it creates information and knowledge out of data. See also, analytics, balanced scorecard, business analysis, business intelligence, corporate performance management, data analysis, data profiling, data warehouse, infographic, information architecture, information design, information visualization, interaction design, interaction techniques, scientific visualization, software visualization, statistical analysis, statistical graphics, visual analytics, references. Further reading, Chandrajit Bajaj, Balakrishna Murthy. Data Visualization Techniques. William S. Cleveland. Visualizing Data. Hobart Press. William S. Cleveland. The Elements of Graphing Data. Hobart Press. Alexander N. Gorban, Bala ZSK Copyright GL, Donald Wunsch, and Andrei Zinoviev. Principal Manifolds for Data Visualization and Dimension Reduction. LNCSE 58. Springer. John P. Lee and Georges G. Grinstein. Database Issues for Data Visualization, IEEE Visualization 93 Workshop, San Diego. Peter A. Keller and Mary Keller. Visual Cues, Practical Data Visualization. Fritz H. Post, Gregory M. Nielsen and Georges Pierre Wonu. Data Visualization, The State of the Art. Stuart Liff and Pamela A. Posey, Seeing is Believing, How the New Art of Visual Management Can Boost Performance Throughout Your Organization, Amicom, New York, ISBN 978-0-8144-0035-7, Stephen Few Fundamental Differences in Analytical Tools, Exploratory, Custom, or Customizable. External links, Yao, Nathan, Visualize This, The Flowing Data Guide to Design Visualization and Statistics, Wiley, PA 384, ISBN A978-0470944882. Milestones in the History of Thematic Cartography, Statistical Graphics, and Data Visualization, An Illustrated Chronology of Innovations by Michael Friendly and Daniel J. Dennis. Peer-reviewed definition of data visualization with commentaries, The Data Visualization Academy, 1, http, bigdatavisdk/, Visual Complexity, The Art of Data Visualization video produced by Offbook.